right, welcome. In this technical explainer, we're going to demystify the whole process of migrating your traditional network over to a Cisco software-defined access fabric. My goal here is that by the end of this, you'll have a really clear, practical roadmap for what can be a pretty powerful transformation. Now, throughout this whole guide, we're going to be treating Cisco DNA Center as our single pane of glass. Think of it as the engine that's going to drive this entire transformation. It's our centralized platform where we'll design, provision, and apply policy to build out a network that's truly automated, secure, and, well, intelligent. Okay, so here's our game plan. We're going to start with the fundamentals. Get to know the core components that make up the fabric. Then, we'll dive deep into the two main migration paths you can take. And to wrap it all up, we'll look at how to bring your wireless network into the fold. And, this is the big one, how to unlock the real power of policy. So, let's get into it.
Okay, section 1. So before we get into the real nitty-gritty, the command lines and all the configuration screens, let's just start with a high-level look. What are the two main ways you can even approach migrating your network?
So you've basically got two main strategies to pick from. First, there's the parallel install. The best way to think about this is like building a brand new house right next to your old one. It's a completely fresh start, perfect for, say, a new greenfield site. The other option, and this is the one we're really going to focus on today, is an incremental migration. This is more like renovating your house room by room. And honestly, for most existing networks, this is going to be the way to go.
All right, before we can even think about migrating, it's absolutely crucial that we understand the roles of each component in the SD Access fabric. This isn't just a random list of devices, right? It's a whole system where every single part has a very specific job to do. So let's break down these key building blocks. So right at the heart of the entire SD Access architecture, you have the Cisco DNA controller. The best analogy really is to think of it as the central nervous system of your network. It's the brain of the operation. It gives you that GUI to design, provision, and monitor the entire fabric, and it abstracts away all of the crazy complexity underneath so you can focus on your intent, not on configuring a bunch of individual devices. Okay, so these 5 components, they all work together to bring the fabric to life. You've got your identity services, that's usually Cisco IOC, and it handles the who, authenticating users and devices and tagging them for policy. Then there's the analytics engine, which monitors the what, giving you this amazing visibility into network health. The control plane nodes, they track the where, managing the massive host tracking database. Border nodes are your gateways to the outside world, the WAN, the data center. And finally, the edge nodes. Well, that's where your users and all their devices actually plug in and connect to the network. All right, now we come to a really critical decision point in your migration. How are you going to handle your IP subnets? And trust me, this choice is a big one. It's going to have a huge impact on your overall strategy, your timeline, and just how much prep work you're going to have to do. So take a look at this. This topology should look pretty familiar to a lot of you, right? It's that classic 3-tier architecture with separate blocks for services, your WAN, and internet access. And look, it's a stable design for sure, but it's also really rigid. It needs a ton of manual configuration, and it relies on VLANs and IP-based access lists for segmentation, which, as you probably know, can get incredibly complex to manage. This right here is our starting point.
So it really boils down to this fundamental decision. Path 1, do you start fresh with totally new subnets? This is definitely the cleaner approach, and it lets you optimize your IP space, but it also means more prep work, right? You got to update DHCP scopes, firewall rules, the whole 9 yards. Or path 2, do you map your existing subnets into the fabric? This is often way less disruptive to your current IP-based policies and services. Let's dig into both of these options.
Okay, let's tackle option 1 first, creating brand new IP subnets just for your fabric. We're going to break this down into a really clear step-by-step process. Think of it in 3 phases: the initial setup, the actual fabric build, and then finally onboarding your users. And this diagram, this perfectly illustrates the whole overlay concept. The key thing to get here is we are not ripping and replacing your existing network. Instead, we're using it as a stable underlay. That's just the physical transport for all the packets. Then, right on top of that, we build a new virtual network overlay, and this one has its own dedicated IP scope. This is the magic that lets us introduce the fabric without having some kind of massive disruptive cutover day. So these first 5 steps are all about laying the groundwork inside Cisco DNA Center. The whole goal here is to give the controller all the info it needs about your environment. You'll install the platform, use its discovery features to go out and find your existing devices, and then, and this is really important, you'll model your physical sites. This site hierarchy is what lets you apply configurations and policies based on physical location, which is a huge benefit of this whole architecture.
And here's what that discovery looks like in action. Inside the tool, you just give it the IP range of your network and the credentials it needs, like SNMP for monitoring and SSH for configuration. DNA Center then just goes out, probes the network, finds all your compatible switches and routers, and pulls them into its central inventory. This is really that first step toward having true centralized management.
Okay, next up, you'll head over to the Design tab, and this is where you create a logical model of your physical world. You'll set up a hierarchy, areas, buildings, floors, and this structure is so critical because it lets you assign policies and device configs to their correct physical spots as you build out the fabric. For example, you can define a set of network settings that automatically apply to an entire building.
It's pretty powerful.
Now, this slide is cool because it shows two critical steps side by side. Over on the left, we're in the network settings, configuring those big global parameters like your DNS and AAA servers that the entire fabric is going to use. Then on the right, we're actually creating that brand new IP address pool that will be dedicated to our new fabric overlay. This is the pool that clients will get their IP addresses from when they connect to the fabric. All right, with all that preparation out of the way, now we get to the fun part. We can start actually building the fabric itself. This is where we shift from just describing the existing network to defining the new, software-defined one. We'll create our logical segments, which are called virtual networks. We'll assign devices to the sites we already created, and we'll start giving those devices their specific jobs within the fabric. And this is one of the things that's so great about DNA Center, just how simple it makes device provisioning. I mean, look at this. In the provisioning section, you just select a device from your inventory, and with a simple little toggle, you assign it a role. So in this example, we're making this device a border node, which is going to be our fabric's gateway to the rest of the enterprise network. It's that easy.
So what are we doing here? We're configuring the Layer 3 handoff from our fabric to the rest of the world, to the external network. This is where we tell the border node how to talk to everything outside the fabric. And we're usually doing that with a routing protocol like BGP to advertise the fabric's new subnets. This step is what makes sure that traffic from outside the fabric actually knows how to get to the devices inside our new overlay.
Okay, now for the final phase, onboarding and verification. This is kind of the moment of truth. We'll activate the network for our users, connect our very first endpoints, and, most importantly, we will verify that everything is working the way it should. Once we've got that confirmation, we can create a nice, repeatable process to expand the fabric across the rest of the campus, maybe one switch or one wiring closet at a time. Now, this is a really critical step that ties things together. Inside the Fabric Services configuration, we're editing our virtual network. You can see it's called Campus here. And we're associating it with that IP address pool we created way back in Step 5. This is the action that connects the logical network segment to the actual IP addresses that users are going to get. It also tells DNA Center what default gateway to configure for all those clients. So, how do we get users on? Simple. We need to assign specific ports on an edge switch to the correct IP pool. As you can see, when a user plugs into one of these designated ports, DNA Center just automates the entire configuration, pushing down all the necessary VLANs and settings. The user's device then gets an IP address from our new Fabric subnet, all handled by DHCP.
And after all that provisioning, this is what you get. DNA Center gives you this complete topological view of your new Fabric domain. This visualization is just incredibly helpful for troubleshooting and really understanding how all the pieces, the border, the control plane, the edge, are all interconnected. At this point, the fabric is built, it's provisioned, and it is ready for traffic.
Okay, so that was option one. But what if creating new subnets just isn't going to work for you? Maybe you have applications with hard-coded IP addresses or just super complex firewall rules. Well, now let's explore the second major option, which is all about migrating your network by mapping your existing IP subnets and their VLANs directly into the fabric.
And right here is the #1 reason you'd choose this path. By using your existing subnets, you cause minimal disruption to all those services that are tied to specific IP addresses. You don't have to immediately run off and rewrite all your firewall rules or reconfigure DHCP scopes. That can save a ton of time and honestly reduce a lot of risk during that initial migration phase.
This diagram is super important for understanding how this works. What it's showing is how hosts in the exact same subnet can live in two places at once, some inside the new fabric and others on your traditional access switches. And how is that possible? It's all thanks to a Layer 2 trunk that connects the traditional network to the fabric's border node. The border node is basically acting like a bridge, stretching that existing VLAN from the old network right into the new SD Access Fabric overlay.
Now, for this Layer 2 handoff to work correctly, there is one critical verification step you cannot miss. You have to make sure that the border node is in VTP transparent mode. This is a technical requirement because in this kind of design, the border node needs to manage its own local VLAN database to do that mapping, and it can't be getting influenced by a central VTP server.
And here's how you actually set this up in DNA Center. It's basically a two-step process. First, over on the left, you check a box to enable Layer 2 extension on your virtual network. That tells the fabric, hey, this VN is going to support these handoffs. Then on the right, you go to the border device itself and configure the Layer 2 handoff, telling it exactly which VLANs you want to extend from the old network into the fabric. After that, DNA Center just automates all the underlying trunk configuration for you.
All right, we're almost there, but a full migration isn't just about wired devices, is it? To really complete the picture, we need to talk about how to integrate your wireless network and, most importantly, how we unlock the real superpower of the fabric, that policy-based automation.
So to make sure you have a really smooth wireless experience during this transition, these best practices are highly recommended. But of all of them, the most critical one is this. Configure the same SSIDs on both your new Fabric-aware wireless network and your legacy one. Why? Because this lets users roam seamlessly between the two environments without dropping their connection, without having to re-authenticate. That is absolutely essential for a good user experience during a phased migration. You know, this slide really gets to the heart of why we're doing all of this in the first place. Once you've migrated to an SD Access Fabric, you can finally move away from managing those complex, error-prone access control lists that are all based on IP addresses. Instead, you get to create simple, automated, group-based policies based on user and device identity. And that is a much more scalable and, frankly, much more secure way to do network segmentation and access control.
And that brings our technical guide to a close. But I want you to remember, the network migration itself, that's just the first step. The real journey actually begins now as you shift from managing boxes and interfaces to defining intent and policy. You've just built a foundation for a more automated, agile, and secure network. So the question is, what are you going to build with it? Thanks for joining.